Thank you for watching Hack the File. I'm Michael Lopez, and today's episode we're going to be doing the next video in the ethical hacking book series. Enjoy. All right, let's get this started. So we're back. In the last video in this book, we stopped at hiding the Trojan in a Word document. We're on creating an Android Trojan. And in this one, we're going to basically install a VM, an Android VM, to test it. So this one should be interesting. Let's see how far we can get through this and see how much fun we can have with this. I'm pretty excited about this. Um, if you haven't heard from me in a minute, it's because I am passing a kidney stone. So I have lots of problems, health issues going on right now. Hopefully, this is the last thing. But yeah, I passed the kidney stone this last week, and I have been in tremendous pain. The pain has gone away, so hopefully it either passed or it's in my bladder. But I think it passed or it's lodged somewhere. Who knows? Anyways, it's not one thing; it's another, you know. But you gotta try to take the good things with the bad. All right, so we'll just pick up where we left off, and let's have fun. So, creating an Android Trojan. The process of creating Trojans for Android devices is almost identical to that of creating Linux Trojans. The directory structure might differ, but as you did earlier in this chapter, you'll modify an installation package to install your implant. The Android installation package is called an Android package APK file. This file contains everything the Android operating system needs to install a new app. Let's begin by using MSF Venom to generate a malicious APK. Create a new desktop folder called Android Trojan and then navigate to it. CD is going to Home, Desktop, Android Trojan. So you want to set on the desktop, but we're not going to do that, right? So we're going to go into my HackTheFile file, and we're going to do I'm going to create a new folder, and I'm going to call it Android Trojan. Right? Yeah. Next, generate a new malicious APK that contains a reverse shell implant. So he's in his Android Trojan file. I'm going to go in mine, and I'm going to type this in. You guys can pause it or you can follow along. Type this command in yourself, whatever you want to do. This command generates a new Android APK with the malicious code embedded within it. In the next section, we'll disassemble this application and discuss its structure so that you can create your own Android. Alright, so let's move this over and copy this. So I'm going to come into my Android Trojan, right? And I'm going to open a terminal here because inside this file is where we're going to create the Trojan. Okay. Now I'm going to generate the malicious APK. So we'll do MSF Venom. lhost equals, then we need my Kali address, so I keep forgetting what this IP is, so listening port equals 443. I'm gonna call it malicious APK. See if that works. Next, generate a new malicious APK that contains a reverse shell implant. No platform was selected. Choosing MSF module. No ARC selected. ARC. No encoder specified. I'm putting raw payload. No platform. That's fine. No architecture. That's fine. I guess it didn't. He didn't. They didn't want it. All right. Looks like it worked. This command generates a new Android APK with malicious code embedded within it. In the next section, we'll disassemble this application and discuss its structure so you can create your own Android Trojan. Deconstructing the APK to view the implant. The command in the preceding example did all the work for you. To understand how it hit the implant, let's decompile the malicious APK, install file, and explore its directory structure. Let's decompile the malicious APK install file and explore its structure. We'll use APK tool, a reverse engineering tool, to decompile the APK. Run the following command to download and install APK tool. Kali, he's in his desktops. He's doing it in the same folder. Sudo apt-get install APK tool. All right, let's do that. All right, that's going to be downloading. All right, that looks like it worked. Let's see what else it wants us to do. To decompile the file, run the following command. So he's in his desktop. He's still in the same file, apk tool dmalicious.apk, and it'll give me all this stuff. The tool will create a folder called malicious that contains the decompiled files. Navigate to this folder and list all the files in the folder in the directory using the commands cd malicious. Desktop, Android, he wants to go to malicious. Desktop Android, he's in the file, he wants to see what's in it. You should see the following files in the folders: Android manifest.xml, apk-tool.yml, original, res, and smally. The Android manifest.xml file describes your app. The following is a snippet from it. So he's opening up the. Alright, let's do all that. So, and like I said, you guys can pause it and follow along um, if you want. How do you clear this? Do you go clear? Yeah, there you go. Let's see where I was at. Alright, let's see what. I want to see if what it did first of all. Malicious APK. Okay, it created it. So, I'm going to say APK tool D malicious dot APK. Alright, so that's the tool we just downloaded. We're using it. Unknown files, original files. Now let's see what it. So it created this file, malicious. So let's cd into malicious. Now we're in malicious. Here's our directory. We're going to see what's in it. So I want to see a list. Android manifest XML, YML, original. Yes, so those are the tools that. Those are the files that said was supposed to be in it. Now let's. Said it wants to read Android manifest. So I want to copy this just to make it faster. I'm gonna cat. Oh, why do I always do that one? So this is an XML file, and if you've never messed with XML files or used them in any kind of way, they're really cool. Basically, you can write them to where you can use them to do all kinds of little small commands, XML commands, and you can change all this stuff too. It's basically a fancy config file, is how I see it. XML file. All right, but it does way more. Okay, so here, cd malicious. You should see the following files. Okay. All right. So that's just a little. I guess it wants to see that XML file. This file includes your app's permissions, like camera access or access to your call logs. 1. Okay, let's see where one is. Uses permission Android permissions, call log. Yeah. It also contains information about your app's entry points too, which is the first file your app runs when it starts. Activity Android label, string app name, main activity Android, theme no display. The APK tool.yml file contains information on the APK, including its version number and types of compression. The original folder contains a compiled version of Android manifest.xml, a file containing its hash and file containing information on the signatures. These signatures are similar to the ones we discussed in Chapter 6. I'll discuss these more in detail in the next subsection. The res folder contains the application's resource, such as images or strings. Lastly, the Smalley folder contains assembly files associated with the app. It's also where we put the implant. Okay, hold on. Assembly files. You can view the assembly files associated with the Metasploit implant by running ls on the Smalley /com/Metasploit stage directory. So malicious ls Smalley com Metasploit stage. A Smalley blah 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 receiver payload blah blah. Should we try that? Well, here's the assembly file right here. I don't know if I need to do that. If you spent time working with mobile apps, you might have expected to see a .dex file. These files contain the bytecode, the 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 bytecode that the Android runtime ART executes. The reason there isn't one is that Smalley is assembly representation and .dex is a machine representation of the app's code. The payload.smalley file contains the code associated with our malicious implant. A will transfer this file into another APK to create a Trojan later. Let me read that again. I was thinking about something. .dex is the machine representation of apps code. The payload.smalley file contains the code associated with their malicious implant and will transfer this file into another APK to create a Trojan later. For now, let's inspect the main activity.smalley file. Class public element exploit virtual methods protected blah 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 blah. Invoke static, invoke virtual. The malicious APK starts main service. Invoke static, main service. A malicious Android service written by the developers of Metasploit framework. This service will eventually load the payload in the background. If you wanted to start a malicious payload activity immediately, you could add the following snippet in the preceding example. On create. So main service, start service, on create. Similarly, you can create your own Trojan by decompiling an existing APK, copying the Metasploit folder to the Smalley folder, and then adding the preceding snippet to the main activity. Okay, yeah, that makes sense. Rebuilding and signing the APK. Now that we've inspected the file, we can rebuild it by running the following command. He's in desktop, he's in Trojans again, he's going to use the APK tool build, and he's putting the directory. I don't think we need to do this directory, or maybe we do. Malicious to APK. All Android apps must be signed before they can be run on Android devices. You can do this with the Java key store. Okay, so let's run this command first. Let's see if we can get this rebuilt. clear. We're in the malicious. We want to back out. And now we're back in Android. Desktop, hack the file. Android, Trojan. I want to see what's in here. And malicious APK. Okay. So he's saying rebuild and sign the. Now that we've inspected the file, we can rebuild it by running the following command: APK tool build. Now, um, what I can do is I can do this. I can say uh, malicious. Picked up Java options. True. Using APK2. Dirty. Root directory exception. Home Kali D. Malicious. Um. So in the book, he had home and then he has a desktop, but my directory was different. So that little squiggly line is the same as putting this home right here. It's the same thing. I could just take the home out and put a squiggly line Kali, or I wouldn't have to put the Kali. Um, I would just have to put desktop. So home Kali is that little squiggly line. But I mean, who cares? Um, so that's how I did that. If you guys ever that if you ever get confused and it's not working, if you have your directory in a different directory, okay, like I did, and it doesn't follow the book, um, just go back. Just go into where you're at in your maybe in your home, or like open up where your directory is supposed to be. Click up here, and then you can get that directory from there. Let's just copy that, like I did, paste it, and then add the file that you want to. Mine was malicious, so I added a slash malicious on the end of that, and that's the full directory. Like I said, that you could replace this home Kali always with this little squiggly line, and that's easy. You just press like Control, and then it's usually at the top left of your keyboard, and you can just press the squiggly line because that's what this guy did, right? So you gotta know how to read this crap. So see that squiggly line and that slash? That's home Kali. It's a shortcut for that, right? And then he's in his desktop, obviously, in Android, and then he made it. He made a folder on his desktop, put a malicious in it. Mine is in a whole other directory, so I went to my directory and did that. So, okay. So just a little tip, so you don't get lost following this, or so you don't get lost in these books, because sometimes it took me a while to figure out all that stuff, and when you're reading, it's a lot of trial and error. So when you're reading these books, you can benefit from my knowledge. It took me a while to learn. That's what all that means, and I recommend, you could follow the book, but sometimes even that gets confusing. So, I just create my own directories, and I do it in my own, and I just put my own stuff, my directory in it, wherever I'm building everything. We're not going to look at that. Okay, so it created that. Let's see, it did create it, right? Malicious too. So we're gonna ls this. It didn't. Oh, okay, so maybe that was wrong. Bruh, directory exception. Java file, no such file exceptions. Home Cali D. Okay, maybe it didn't work. So let's do this squiggly letter here. Did I spell malicious right? Ah man. So let's see what I'm doing wrong here. After I just said all that. Yeah, it's okay. Oh, okay. I think that's supposed to be separate, right? So it's supposed to be like that. See, and I even use that little squiggly instead of the home. Now let's see if it created it. Oh, what's going on? No path exists. APK2 YML. Let me see. Let me see. Malicious. Let's see what I'm doing wrong. APK tool build directory. I don't think so. I think that has to be. Let's. I don't think you even need to put this because the file's in there, ain't it? Yeah, you didn't even need to put that directory because we're already in the directory. So forget everything. Well, that all that stuff I said is true. Um, sometimes, if you're in the directory, you don't have to do the directory, right? Because you're in it already. So why was he doing it? He wasn't in the directory. He was going to another one. I don't know. But if that doesn't work, then if you're already in the directory with your file that you want to manipulate, then you probably don't have to put the directory because you're in it. The directory's up here. You're in it already. And then it's just going to look for the file and then output a second one, right? Bruh, bruh, bruh. Let's get it. All right. Anyways, that built it. So yeah, if you're in the directory, you don't have to put it. But some programs make you put it no matter what. It's weird. Malicious two APK. Okay, so malicious two is the rebuilt one. Okay, we're gonna clear this. See, there's always something that's going on. There's always something. Let me see how many minutes I got left in this video. All right. Apparently, I didn't have any more minutes left of the video. I'm gonna do another one. Um. All right, let's go to the next thing. Whatever we have to do next. All Android apps must be signed before they can be run on an Android device. You can do this with the Java Key Store, which stores and protects key materials such as the public and private keys used for signing. Key material never leaves the key store. Instead, an application sends the key stores its data, and the key store uses the protected key material to sign or encrypt data and returns the result. As illustrated in Figure 10.10, some system key some systems even store key material in a separate piece of sector, separate piece of sector called a trusted execution environment. App 1, plain text, key store, app 1 entry, private and public keys. Ciphertext, app 2 entry, private, and then keeps going. Run the following command to install the Java Development Kit (JDK), which contains the tools we'll use to sign the Trojan APK. So he's in his desktop again, he's in his Android, sudo app install -y default. Let's do that. So that's where we're at. Sudo app. Y default JDK. Okay, it's downloading. All right. Generate the RSA keys we'll use to sign the Trojan by using this command. Okay. Let's see. Let's read. Let's read. Generate the RSA key we'll use to sign the Trojan by using this command. Key tool, gen key, key store, my dash malicious, key store alias name malicious, key RSA, key size, validity 1,000. Oh well, 10,000. So it's gonna tell us what all that means. But let's enter it in first. Let's clear this. Let's go key tool, gen key, key store, my dash malicious. Dot key store? And that might be a book error. Alias name. I don't know if I'm gonna change the name. Malicious. key alg RSA key size 072. Let's see if that works. Key store password is too short. Must be at least 6 characters. What is your first and last name? What in the fudge? Uh, Kimbo Slice. What? Country code for the unit. Huh. Alright, now let's grab this bad boy over here. We'll use Java's key tool utility to generate a new key, gen key. Instead of displaying the key pair, we store them in keystore file, keystore, called malicious.keystore. So I did that right. Malicious.keystore. The keystore can so that wasn't an error because they had a dot there. I was like, man. The keystore can store multiple entries, each which is identified by an alias. Our entry is called alias name malicious. The next option specifies the cryptographic key algorithm, keyalg. Here we select RCA and set the key size to be 3072. We also set the key to be validity for 10,000 days. Now we use Java's jar signer utility to sign the APK file. So he's in Android again, jar signer, SHA, blah blah blah. Alright, let's enter that in. Remember, we gotta sign it now. So jar signer. Sig Alg. Shaw 2 with RSA dash digest alg Shaw 2 key store my malicious 2 dot apk alias name malicious. See if that works. Name name malicious picked up job options. Please specify alias name. Please type jar signer help for usage. So I did something wrong. Let's try that. Let's look at it. See what I did wrong. Jar signer dash sig alg SHA2 with RSA. That looks good. Digest alg SHA2 key store my malicious 2 so SHA2 key store my malicious did something wrong here. My malicious dot key store apk alias name malicious. Okay, that one should be good now. Okay, let's read what that says. We'll use Java's utility tool. Did that. Okay. First, we select the signature algorithm using SHA2 with RSA. Then we use SHA2 as our hash digest function. Lastly, we specify the key store and the key alias. In this case, we'll use the key store we just created, my malicious key store, and the entry with the alias. So why did it ask me what the... That's weird. It doesn't say anything. Certificate chain not found for alias malicious. Alias name malicious must reference a valid key store key entry containing Private key, public certification chain. Okay, hold on. Alright. Alg. SHA-2 key store. My malicious dot key store. Malicious 2 dot apk alias name malicious. I don't think that worked, but let's move on and then we'll test it because it says it's going to test it here next. We'll come back to that and see why that didn't work or if it did. Testing the Android Trojan. Now let's see our malicious APK in action. We don't want the malicious program on our phones, so let's create a new virtual machine that emulates an Android phone. Google has developed an emulator that is bundled with Android Studio, its Android development environment. I actually have a book that does Android development, and I'm sure I could have got this from there too. Follow the instructions and H developer Android Studio install. Let's do that. Let's see what if it's malicious. Oh, certificate looks good. Connection is secure. It's not HTTP. It's HTTPS. Developer Android Studio install. Okay, to download Android Studio on your host system outside of your current virtual lab, after you've installed Android Studio, create an empty project by clicking Start New Android Studio Project. Following the instructions presented, as a rule of thumb, select the default option. Once you've created your project, create a new Android virtual device by selecting Tools, EVD Manager, or by clicking the Android Virtual Device Manager. Create a new virtual device with the specifications of the device you're targeting, and click the play button to start it. It will take some time to start the virtual machine. Once it is started, you will see an emulated device. Your Kali Linux virtual machine won't interact with your Android emulator because the emulator runs outside of your virtual lab environment. Change the Kali connection settings in the virtual box to bridge adapter so that it connects to the same local as your Android emulator. For instructions on changing the Kali network, run the ifconfig command to get the new IP address of your Kali machine. But why can't I add that into my you can't because it needs a virtual machine. So this is off of my box. So next, start a web server in the folder containing your assigned malicious APK. Next, start a web server. Okay, so Python server. This is the web server that we'll use to serve to our malicious APK file. I'll start the attacker server in the new terminal. So we'll set that payload. Open your emulated device. Navigate to web server. Open your emulated device. Navigate to the web server running on the Kali Linux machine and download the Trojan. Yeah, I'm going to my. Ignore the warnings. Huh. Awesome. Okay. And then there's a bunch of uh, exercises that I would recommend doing, right? And I'm gonna go page by page on those exercises, and you could pause them and read them, do them yourself, or you could buy this book. But this is what I'm gonna do on this, since okay, on your host system. So it wants me to download this onto my laptop, and I used to have this on here, Android Studio. Um, Trying to figure out if I can get this on a yeah, see? Can I just put this now on my Ubuntu? Sure, right? Why wouldn't I be able to download this from my Ubuntu VM using this? Have a VM inside a VM? And then I wouldn't be able to. Yeah, I don't know. I don't feel like thinking too much. Okay, set up Android Studio in a few clicks. Download the latest version of Android Studio. Mm, 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 Download Android Studio Hedgehog. It's a patch. No Windows machines with ARM based CPUs are currently supported. Here are the system requirements for Windows: 8 gigabytes of RAM to install Android Studio. If you download an exe file, double click it, launch it. See what I did. All right, so I've got that emulator, I guess, up. I had to come here on the side of these options, and there's a running devices here, and then I just had to read and then add that, like use the plus button. Um, and it added. It just took a while to load. It's the one that I created, the project I created. So here's the virtual phone. Okay, so that's one we're gonna hack, or we're gonna try to hack. I got a feeling it ain't gonna work, but all right. Create a new virtual device with the specifications of the device you're targeting. Then click the play button to start it. It will take some time to start the virtual machine. When it is started, you should see an emulated device. That's what we got. Your Kali Linux virtual machine won't interact with your Android emulator because the emulator runs outside your network. Change the Kali connections to VirtualBox to bridged adapter. Alright, let's do that. So we're gonna go to here, and we're gonna go Kali Linux, and we're gonna have to um, stop it, or else you can't change anything. Come in here, we'll go to network, and we'll go to bridged. Okay, and then we'll start it. Okay, run the IF to get the new IP address of your Kali Linux machine. So we'll power up. This takes a little bit, but this is pretty interesting. It's pretty fun. So if you want to practice hacking mobile phones, you have another source now. You can use Android emulator to do it. I'm gonna run this, and if it doesn't work, I don't know what that was. Um, I'm gonna run this, but I mean, if it doesn't work, fine. I'm not gonna spend a lot of time doing it. Um, I'm gonna get it to try to run, and because I don't think that last config file thing I did was right, but I'm sure it's just a password thing. I have no clue. Okay, so now open a terminal here. Okay, so it's 192.168.0.103. Run the config file to get your new IP address of your Kali Linux machine. Okay, next, start a web server in the folder containing your assigned malicious APK. Let's do that. Oh, what's happening? Running a lot of stuff on my box right now. That's why. Ooh, Android. Here's my malicious. It says let's open the terminal here, and we're gonna create a Python 3 server. What is the damn? HTTP dot server. Remember that -m. I always forget. Can never remember. Oh, come on, man. Okay, so we're creating a server in this directory so it can snatch this up. Next, start a web server. Got that. This is the web server that we'll use to serve our malicious APK file. Now start the attacker in a new terminal. So close that. We'll open up a terminal here, just in the desktop. Um, yeah, I guess they like to open theirs up in home. So we'll open up a terminal in home. Or that's where it opens up when you open up a new terminal here. It just opens up at home. So we'll do that. Uh, so sudo msf console minus q minus x use exploit multi handler. I hate when they use this blanket thing. That might have worked. Open your emulated device, navigate to the web server running on the Kali Linux bot using okay, let's see. Run and exit. Why is that an unknown command? Run exit. That's what it says. Says run. Oh damn. It's not gonna exit. Man, I could just exit, right? Damn it, that's supposed to be a semicolon right there, whatever that is. I keep forgetting semicolon. And that's supposed to be right there. That's why it doesn't recognize that. But I'm just gonna leave this. I could just exit. Alright, so that looked like it worked. At least I opened up a uh, uh, using configure payload. Is it listening? Oh, because it didn't run. Yeah, it didn't run the run. And I'll just exit it. Okay, so it's good. It's listening. Alright, so now it wants me to open up my Open your emulated device. Navigate to the web server running on Kali Linux machine and download the Trojan as shown. Oh, so it wants me to go to this. How do you get on this stupid web right here? Right here? What's the 192.168.0.103 0.103. Delicious 2 dot apk. Welcome to Chrome. Let's see if that works. So it's not letting me. But we're going to install it because this is just a app's not installed as package appears to be invalid. See, I'm thinking that I didn't do that thing right. But this is pretty cool if it worked. No, it looks like it's just stuck. So this server says, yeah, it got it's getting the malicious package. This isn't picking nothing up because why I didn't download it. Yeah, it's just tripping. Yeah, it's gonna take forever to go back on. Alright, let's see what happened. I wanna see my malicious package. Why that didn't. Look back and see what I think it didn't. Rebuilding and signing. Now that we've inspected the file, we can rebuild it. Run the following APK to build. Whoa, this is way. I've got the malicious 2 APK right there. Copy. I think that worked. I don't know if this jar signer worked. Digest alg show to key store my key store. Oh, my malicious key store. Malicious 2 apk alias name malicious What was the paraphrase? Shit. What was the password? I don't remember. So no Shaw 2? Mrs. Digest not available. So no Shaw 2? So let me see. Let me see. Digest. That's not gonna work. Can we try? Can we try? Maybe that's not. Do we have to have this? I don't know. Damn it. to see what's going on. Obviously, that I'm doing something wrong or that command is obsolete. Says it's good. And that's pretty cool. Finding children in Word document, create an Android. Huh. Yeah. Let's see. This is straight out the book. Sudo install. So these are capitals. All right. So I copied this error, right? So whenever you get an error, just copy that error, okay, and then type it in your Google and see what comes out. And this one says it's a the error you are. I mean, okay, the error message you are seeing indicates that SHA-2 message digest algorithm is not available in your Java environment. This error can occur when you're trying to sign a jar file using version of Java that does not support SHA-2 algorithm. And I think that's what it's saying. To resolve this issue, you can try the following steps. Check that you're using a version of Java that supports the SHA-2 algorithm. You can check the version of Java you're using by running Java version. Let's try that. It looks like it's using an old Java, 2017, but I don't know. If you're not using a version of Java that supports SHA-2 algorithm, you can try upgrading to a newer version of Java. If you're already using a version of Java that supports SHA-2, you need to update your Java installation. So we're gonna update our Java. Okay. Clear this. So this guy's got Java 11. What Java do I have? Java. Yeah. Okay, so this guy's got his Java Open JDK version 17.9. So I've got the latest version, I think. Yeah. Let's see if this has the SHA. I'm just gonna ask Google. Does version have SHA-2 algorithm? Yes, Red Hat build OpenJDK 7 supports SHA-2 algorithm. Says it does.
Type apt get update.
I'm just gonna see what is the newest. The latest version of Java Development Kit available for Kali Linux is 17. You can install it by running the following command. I already have it. See? Okay. Says it has the Shaw algorithm. See, and this is going to take a lot of. I mean, this is going to take some more troubleshooting to see what's going on. Warning: the signer certificate is self-signed. The SHA-1 algorithm specified for this is considered security risk disabled because it's outdated or what? Yeah. Well, let's see if that worked a little bit better. Let's see if we can re-download that. See, maybe it did something. What did I crash this? Let's try this one more time. We'll try this one more time, and then um, I'm gonna have to do some investigating in what's going wrong with it. But I mean, it's not a big deal. It's something to where what the heck is that? Um, Let me go look at this. We know what we're doing, what we're trying to do. We just can't get that. These dang. Um, encryptions and stuff to work, I guess. HTTP. We'll try to. 168.0.03 slash. Come on, no whammies. Okay, so obviously it's I gotta change the version of this phone to a newer version. Um, I don't want to make this video that long. That's gonna get froze or something. Um, okay, that's good. So I'm gonna basically this is an old ass phone apparently Pixel 3.8 Google phone. I'm gonna change the pair device using Wi-Fi. Oh heck no. Um, so I don't know. I get. I mean, we get. I guess we get the gist of this. Okay, so if I could, you have your thing, play around with your virtual phone. You're gonna want to make it a newer phone, obviously. 2023, 2022. This one's old. Pixel 3a. I don't know what that is. And you're gonna want to make it a newer phone. This is a old ass phone. And I can do that, but I just don't have time to be doing all that. Obviously, this is I'm getting the malicious APK file. Um, I have to figure out. I mean, this. I mean, it creates the malicious APK. Um, the only thing is, I don't know if it works or not because I can't get it to run on the right phone. That's an outdated phone. But you get the gist of it, right? And see, and I have not been having any luck with those um executable Trojans. Now that one we have to figure out why my SHA-2 is not working. Maybe I didn't type the command in right, but I don't think so. So, and I even looked this up online, and this is the exact same steps they tell you online, which they probably took right out of the book. My SHA-2 is not working. For some reason with my Java pack or something. So what I would do is I would look up these, right, and this jar signer and see what other. I mean, you could probably type in jar signer help, or whatever. So if I go in here, uh, running Kelly. I'm actually gonna exit this. Or what is it? Exit dash Y. Anyways, so let's go to let's see if we can just mess around just a little bit. That way I feel better about myself. So jar cider. Let's see if jar cider has a help. So key store URL, key store location, key store password. What were we looking up? Digest algorithm, name of digest algorithm, and it doesn't have any options of digest alg. I'm sure it was this one. I'm just gonna mess around with this a little bit. No, because I didn't make one, huh? Shot three. Oh, what's that noise? I want to know where my options are for the. What does that say? Anyways, If we can get this to work, and then we update our phone, virtual phone, uh, we should be able to get that payload to work. I don't want to spend a lot of time doing that. So you guys can. This isn't a big deal to me. I mean, we this is gonna take me a day to figure out, and usually it's everything's obsolete. So if this, what I would do is your next thing, I would find out what, uh, like I said, do this error, but find out what other algorithms jar signer has or whatever. Man, this sun is right in my face. So I'm just gonna type it real quick. What? So I guess that SHA one you could use RSA with MD5, SHA 256. So we can even do right. Let's see. Jar signer. I don't even know why it's giving me problems. At this time, jar signer can sign jar files using either DSA with SHA-1 or RSA with MD5. That is, if the signer public private key DSA, jar signer will sign jar. SHA-1 with DSA algorithm. If the signer keys are RSA key, jar signer will attempt to sign jar using the MD5 with RSA. So we could try MD5. There you go. I don't know if that worked. Picked up Java option. Yeah, there you go. Jar signed. So it's gonna be the MD5 with RSA. I guess SHA-2 doesn't work anymore, and it says it does on Google, but I think it's full of crap. Google sometimes. I mean, Java probably supports it, but this jar signer doesn't. So it says right here, jar signer supported algorithms. It uses DSA SHA-1, so I could have put, but I mean, if I'm using RCA, so it has to be MD5, which I think makes sense because isn't SHA-2 like way outdated? Isn't MD5 the more secure one? I don't remember right now, but we figured that out, so that worked. Now what we can do is we can try to. So this, hopefully this updated that, right? Turned it. Let's see if we can actually try to download it again, try to run it again, see if it works now with the. I mean, this is the whole part of troubleshooting. This might be a long video. Trying to open this Android Studio. I don't know why it's not working. Where the heck is my Android Studio now? Where the heck is my Android Studio? Should be open here somewhere. See if I can. Nope. Android Studio is not. Restart it. This might be a little long video. I don't know if you guys get the patience. Let's see. All right, we're back. So this is like 2 days later. I'm coming back on here. I had to take a break. Had some stuff going on in my family and some health problems. So, but we're gonna get back on here, and I'm gonna do a recap and a summary on this cool little thing we did and what we learned. Nothing is a waste of time. So let me go into my. Anyways, okay, so I had to redo everything, right? And I've got a Python server open here, and you can see right here today try to download the malicious 2 APK that we did. I have a new IP address, so I had to enter all that in. I started my attack server here, waiting to hear back, waiting to hack in to the Android, and this is what I keep getting. App not installed. So everything is working up until I am trying to download that APK file to this phone emulator. Now, there's a lot of possibilities, right? So I went to here and uninstall. install unknown apps, and Chrome is allowing it to do that, and that's where I'm downloading it. And then I also went to um, let me see, unrestricted data, and I let everything be unrestricted. So I don't know what else to do with this emulator. Now, this might not be the right version. We might what I'm guessing is that we have to find the right version of this emulator that will download that app. Now, I have some ideas, right? But I mean, it's going to take too long. For this is already a 2-hour video. Um, I have some ideas on why it's not doing it, and I would have to look at the the malicious file to see. So go here, go into this when we decompiled it, and see in this what do some more research inside that and see what's going on. Maybe that's not set up right. Maybe we have to change that. The first app that it's downloading is our malicious file, but I don't see anything wrong with how we created it in the book. It's actually right here somewhere. That's rebuilding it. So this is creating it here. Anyways, it's not really important. I mean, it is important that we get it to work, right? But when you get snagged on something as stupid as something like this, where I can't download the APK onto this phone. I mean, that's a very important thing though, because you have to figure out. So let's say you're attacking somebody, and you do all this, and they can't download it into their phone, right? So you need to find out what version of phone they have and all this stuff, and you need to be able to get that to download, right? And stuff like that. But those are other things you can work on, right? And you can practice and stuff like that. But for now, that's going to take a lot of research, and hopefully enough times we do this down the line, we'll have the answers for it. But right now, I just don't. I mean, I've been working on this for a couple days, and I cannot get this to download. And I've changed this phone emulator 3 times. This is the best running one so far. And yeah, I'm just gonna have to say, I learned a lot from this. The next step that you have to put in your mind is getting it to install on here, and then it should work. You should be, because it'll install, it'll set off the payload, and then this right here will hack you into their phone, and it says, you know, it wants you to do a geolocation if you possibly can, and see you can geolocate. You can see where they're at. You can help, and you can find out all the commands, and you're in, right? So I mean, was it successful? I would say it was like 90% successful. It did, this whole little video. The only thing is, I couldn't get this to install. Now, if you guys know what I'm doing wrong or what's going on, hey, leave some comments. Let me know. Let me give me some ideas so I can get it running. Other than that, I can always come back to this in later on and get it running, or you guys can work on it on your own, right? Um, but what I learned is just repetitive doing the same thing. Using the MS Console to set up the tag server, creating I learned a lot about Android, on how to create the Trojan, right? Um, and how to decompile it, what tools to use, and I wrote down all the instructions. So if I come here, like I always do in my videos, I write down the instructions, and here's all the instructions for how to do all this stuff, right, from the book or whatever. Just in case I forget, I've got references. Oh, that's right. This is how I do it. And um, I think we're gonna move on. I'm gonna shut all this down, and I'm gonna move on to the next one. But I'm gonna try to make this video a little bit shorter because I think I'm just gonna keep this in where I show you how to do everything. But the troubleshooting on this was a lot of troubleshooting. There, like the let me see, where's it at? When we were creating the hash on this, or the hash, the SHA-2 didn't work, so I had change it to SHA-256, and that might be a reason why it's not. But SHA-256 is, I googled it, is the most well, it's not the most secure, but it's a very secure hashing algorithm. So that should work, right, with all modern, even the virtual phones. So I mean, I don't know what's going on, but this, we had to change that because we were having that. As you guys should remember, we were having a problem with just putting SHA-2, and that's what it shows in the book. So we got everything on this end to run and to create the signatures and all that. So right here, um, we created the key, and then we created the signatures somewhere over here, or we signed it. I mean, everything worked. Okay, we were having a lot of troubleshooting, so we troubleshot this side at least, and we got it all run. Um, the let me see, where is the signatures? So we accomplished some good stuff, and the only thing we can't do is we can't get that. We can't get our Trojan to install on here, but that's another problem we can save for later. And then that's how we're gonna wrap that up, and I'm gonna call it 90% successful. I learned a crap ton. So let's continue here. An attacker could encourage a user to download the malicious APK by sending them a phishing email or text message linking to a clone version of the Google Play Store website. Chapter 7. Alternatively, a hacker could use a QR code to see the QR code all over the place. For example, in a conference room, parks, and hacker could easily make the QR code link to a fake website that contains a malicious Trojan. Shows an example QR code that links to No Starch Press site. You can scan it by opening your phone's camera and app. So this would be what the best, I would say, the best chance of well, I don't know about the best chance, but I would say a good chance of getting this payload off, because people love to scan QR codes. So you go to a restaurant, right? You sit down in a restaurant, and they've got that little card that says, scan this QR code, and pay for your bill, or pay for your, or get your points and all that. Buffalo Wild Wings or something like that. You can go in there and you can like make your own. Like, I would say, steal their plastic little cards they give you. The plastic papers, and cut out their QR code, paste in your QR code, relaminate it, right, or whatever, put it back in there, and have that go to their website, but then redirect to yours first. Download your malicious app. You could do all kinds of stuff, man. This is what's cool about cybersecurity is that you can get very creative with your deviousness, right? And just the sky's the limit, right? And that would be a cool one to get running, right? As long as we can get this stupid, the most powerful part of this is figuring out how to get these things to install on people's phones and stuff. And I'm doing something wrong, but we'll figure it out later, but I'm not trying to do that right now. So as long as I understand what tools to use, and actually how to do it technically. The last bit of that is something we could do some more research on. It takes more experience, but that'll be all right. Some of the best mobile phone attacks exploit zero-click vulnerabilities. A zero-click vulnerability allows the attacker to compromise a mobile phone without any action on the user's part. There are really rare and these are really rare and very valuable. A final note on mobile devices. Although iOS devices are generally considered more secure, they aren't safe either. For example, a vulnerability in Facebook's WhatsApp platform allowed hackers to install malware on an iPhone by sending WhatsApp users a link. A state hacker group later used this vulnerability to hack Amazon CEO Jeff Bezos' iPhone. See? Exercises. So this is the part where I'm going to go through. You guys can pause the video and follow along if you want, or you can buy the book. I would recommend buying the book and doing this on your own, but and do these exercises because these exercises look fun, and it might answer the questions we have about the mobile app. About the virtual app um, environment. Not being able to download and install this APK. We sent it. So these exercises will bolster your understanding of Trojans. You'll begin by exploring a tool that automates the process of creating and assigning Android Trojans. And the second exercise, you'll write an implant in Python. Your implant should stream video from the victim's webcam and transmit it back to the attacker server. So this is awesome. Like I said, I'm not going to do the exercises on this series because it's just gonna take way too long, right? I'm trying to get through this book and then go on to a next book. So, Evil Android. Evil Android is a bash script and automates the APK implementation and signing process. Automates the APK implementation and signing process. So it makes it faster, right? You can download it from GitHub by running the following command. So this would be awesome. Get clone HTTPS, get clone, blah blah blah, evil droid. You next need to download the APK of the app you'd like to transform into a Trojan. So this would probably fix our problem. In this example, we'll use the APK file of the Signal app, an encrypted message service that you can find at whatever, to choose another APK available from Google's Play Store. So this would probably solve our problem. After you've downloaded the APK file, navigate to the bash script. Yeah, this I'm sure would, because you're picking actual apps that are gonna be, I guess, up to date. Evil Droid. Evil Droid does it way faster. Maybe there's a problem with my backend. Maybe Evil Droid does it and will make it better, and then it'll install. Right? There could be a lot of possibilities, so you just got to keep going. So this might be the better way to do it than we were doing it hand. I mean, that's all. Sometimes that's the story. So if you do this exercise, pause the screen, follow along here, and do the exercise if you're doing it, or buy the book. But I'm sure this exercise will probably work, right? Right, and then you selected three of the following instructions: prompt, create your children, and then you can run it again and see if you can. Yeah, so I'm not gonna do it. I'm tired of this. I'm gonna move on to the next topic. It's been a lot of days researching, but I learned a lot. Writing your own Python implant. In this chapter, we'll use implants available for Metasploit as an exercise. Write your own implant that takes pictures with victim's camera. Use Python OpenC library. So you're gonna install OpenC library in Python. The script will take several pictures and stitch them together. And there's your implant. Extend your implant's functionality. And then you'll need to create an implant, a basic protocol for controlling your implant. For examples, how to do so, final note. So, using Python, obfuscate your implant. Now you developed an implant, let's obfuscate it. Remember, the obfuscation process makes detection and reverse engineering more difficult. We'll use this tool to obfuscate implant.py. And then here's the tool. I'm gonna go here and nope, can't find it. Yep, it's gone. Pip install. You can just do it like that. Obfuscate, Pia armor or Pi armor, obfuscate implant. So, you're gonna it's gonna obfuscate it. So yeah, that's it. Thank God. That took forever, and I was getting kind of tired of it. So, but I mean, I learned a tremendous amount. I hope you learned a tremendous amount in this video, and I'll see you next time on Hack the File. Have fun.